No question about it. Harvest labor ranks as a major cost for Florida citrus growers. In fact, harvesting can represent about half of a grower's overall production expenses. And for growers of processed citrus who face stiff competition from low-cost foreign producers, getting labor costs down is a top priority. What's more, bolstered immigration policies could lead to labor shortages and higher costs for citrus harvesting. Meeting these challenges, more and more growers are employing an innovative technique for reducing harvest labor needs. They're cutting labor costs and getting healthy yields. Isn't it time that you discover the benefits of mechanical harvesting? Since 1995, the Florida Department of Citrus has funded research for developing innovative and practical mechanical harvesting techniques for processed citrus. Studies by the FDOC show that these harvesting machines can cut harvesting costs by up to 50%, and none have reduced grove life or production. There are a variety of different mechanical harvesting systems available right now for growers, each offering particular benefits depending on grove condition and layout, soil type, and other factors. One of the most recognized systems is the trunk shake and catch system. These machines use a trunk shaker and fruit deflector on a single unit, clamping each tree trunk and oscillating it to shake fruit from branches. A self-propelled fruit receiver is positioned on the opposite side of the tree. Fruit then flows into a bulk handling cart and then to a roadside hauler. Typical harvest rates are 90 to 140 trees per hour. This system removes almost all fruit from the crown of the tree, but may leave some at the skirt. And while a proven performer, it requires uniform trunk spacing in the row, clear trunk height of 15 inches or more to the first branches, and clear skirts to at least 30 inches above the ground. These systems handle groves without concern for top tree height and hedge tree width. A variation on the trunk shake approach is the monoboom trunk shake unit, which can adapt to almost any grove condition. This system is especially suited for older groves with trees having short trunks or trunks more than 9 inches in diameter, situations where traditional trunk shake and catch systems cannot work efficiently. The monoboom power unit operates in the drive alley and zigzags to harvest trees in left and right side rows. The shaker can also be raised to clamp onto major limbs on very large mature trees. Because no catching unit is employed, most of the harvest cost with this system results from hand labor to pick up fruit and glean from lower branches. Harvest rates average 30 to 100 trees per hour. A different approach, the continuous canopy shake and catch system, uses a self-propelled harvester fitted with spiked drum shakers to engage the canopy, shaking it horizontally to remove fruit. Machine operators can adjust the shaker assembly for height and angle to align with the hedged and top tree canopy. Catching and conveying surfaces collect, detrash, and deliver fruit to bulk handling units. Working in pairs, these machines travel continuously along the row, resulting in average harvest rates ranging from 200 to 400 trees per hour. This system works best in densely planted, hedged groves with uniform canopy size, trunk alignment in the rows, and adequate clear trunk height. Topped tree height should not exceed 16 to 18 feet, depending on fruit variety. Hedged width should be 6.5 to 8 feet from the trunk. Clear trunk height to the first branches should be at least 18 inches, and the skirt should be clear from the ground up to at least 30 inches. While the grove preparations are significant, these systems pay off in performance, with each pair of machines capable of harvesting 2,200 acres per season. Because of this efficiency, the continuous canopy shake and catch system offers significant savings in properly configured groves. In densely planted groves where trunks are short and trees are not skirted, growers may use the simple tractor-pulled continuous canopy shake system. This system works in similar fashion to the continuous canopy shake and catch units, but no catching surface is employed, allowing greater flexibility for when tree branches are close to the ground. Oscillating drums travel through the grove at speeds typically around 1/2 mile per hour, shaking fruit from the tree and allowing it to drop to the ground. Hand crews then recover the fruit from the ground and glean from lower branches, which must be considered in the overall harvesting cost. Harvesting rates average 100 to 200 trees per hour. For continuous canopy shake systems, topped height shouldn't be more than 18 feet, and hedged width should not exceed 6.5 to 8 feet from the trunk to keep gleaning costs down. Skirting, trunk alignment, multiple trunk trees, resets, and clear trunk height are not concerns. A good match between the harvest system and grove conditions is essential. Regardless of which system gives the best match for your groves, here are things to consider before starting any mechanical harvesting program. The cost to initially prepare your grove for mechanical harvesting can run $40 to $100 per acre, depending on grove condition and the selected harvest system. Cost in following years can run $20 to $25 per acre for maintenance skirting. After you've set up your grove to take advantage of mechanical harvesting, movement or repair of irrigation systems, removal of branches and trash, and filling of ruts may run $5 to $15 per acre. Trunk bark damage can occur when the cambium is actively growing. To minimize damage, trunk shakers that apply straight line strokes rather than multi-direction strokes are preferred for citrus. The proper equipment, combined with good operator training, will help avoid bark damage. After almost 10 years of mechanical citrus harvesting in Florida, there is no evidence of shortened tree life or reduced yield, but long-term studies are continuing. What's more, mechanical harvesting during Valencia bloom does not appear to reduce yield the following year. Mechanical harvesting after about May 10th might reduce yield for the following crop more than would equally late hand harvesting. Of course, earlier harvesting will help minimize any yield decrease. And selective fruit abscission agents, anticipated by 2007, are expected to help avoid any yield impacts due to late mechanical harvest. As you can see, there are commercial mechanical harvesting systems available to meet the needs of virtually any commercial citrus grove. In the near future, further refinement of these machines and the anticipated availability of fruit abscission agents promise even greater efficiency. The Florida Department of Citrus invites growers to learn more about these systems and discover the benefits of mechanical harvesting. This University of Florida website features an interactive spreadsheet to estimate the potential increase in income per acre when using mechanical harvesting systems in particular grove conditions. Contact the Florida Department of Citrus at 863-499-2500 or visit us on the internet at www.floridajuice.com for additional information and progress reports.